Welcome to Much Ado About Llama, where we explore the real-world latency performance of Meta's Llama compared to ChatGPT 4o and Gemini. In this video, we will explain why RTTA, or real-time to answer, matters in enterprise environments. We will show how each model performs under structured, practical workloads. Our findings build on prior benchmarking studies by Zyda and Fabish. This script will guide you through every slide to ensure clear, engaging delivery for your audience. Let's begin. In this presentation, we will move through a clear structure that includes the motivation for focusing on RTTA, what RTTA represents, and why comparing these specific LLMs matters for users and enterprises. We will then cover the experimental design and workload structures, detail the measurement approach to ensure accurate benchmarking, and present a results snapshot with insights. This will be followed by a deeper analysis of the architectural differences driving RTTA variance, recommendations for practical deployment decisions, and a conclusion summarizing our findings. Latency impacts user experience directly, affecting productivity in workflows that depend on LLMs. Enterprises need models that are not only accurate but also fast and consistent. Zyda's DeepSeek analysis and Fabish's prior benchmarking work demonstrated how latency differences compound at scale. We continue this work by focusing on user-visible latency rather than back-end metrics alone. This study enables engineers and decision-makers to align model choices with workflow requirements. We will show you how RTTA differences affect practical use. Our first objective is to benchmark Llama, ChatGPT 4o, and Gemini using realistic, enterprise-relevant workloads. Next, we analyze how different architectural approaches, such as structured reasoning, streaming output, and live retrieval, impact latency. Our third goal is to provide actionable recommendations to help you select the right model for your workflows. We believe informed decisions require transparent, data-driven insights. Through this analysis, we enable your teams to optimize productivity while leveraging LLMs effectively. Let's see what RTTA means in practice. RTTA, or real-time to answer, measures the time from when a user submits a prompt to when the last token of the output is displayed. This metric captures the entire user-perceived latency, including model processing, token generation, and interface rendering delays. Unlike back-end-only inference time, RTTA reflects what users actually experience during LLM interactions. This helps teams identify bottlenecks that affect productivity. It also supports realistic latency planning for interactive and automated environments. We use RTT as our primary benchmark metric throughout this study. Our testing covered 25 workloads, including technical queries, RAG workflows, code generation, and translation tasks. Each workload was designed to reflect practical enterprise scenarios. Testing was conducted using paid, stable versions of each LLM under consistent network conditions. We standardized prompt structures to ensure fair comparisons across models. Each workload was tested 3 times per model, and the results were averaged to capture consistent patterns. This ensures the results are directly applicable for enterprise planning. In this slide, we explain how we measured RTTA for consistency. We used a manual stopwatch approach, capturing the time from prompt submission to final output for each LLM. Each workload was run 3 times to account for variability, and results were averaged for consistency. Using a llama as the baseline allowed us to compute comparative ratios easily. This approach reflects real user experience rather than synthetic API latency. It ensures the benchmarking data is meaningful for teams planning LLM deployments. Here, we present Table 1 showing RTTA across all tested workloads for Llama, ChatGPT 4o, and Gemini. This snapshot provides clear numeric evidence of where each model excels and where it lags. By examining this table, you can see workload-specific performance and latency differences in practice. It allows technical teams to match their workflow needs with the right model. Understanding these numeric differences will improve deployment decisions. We encourage you to review the table to see specific data points that matter to your use cases. Multiple factors influence RTTA variance, including caching strategies, infrastructure, prompt complexity, and architecture. ChatGPT's streaming reduces perceived latency, while Gemini's live retrieval can introduce delays. Prompt complexity can also extend RTTA as models require additional processing. Hardware and backend optimizations further affect user visible latency. Understanding these contributors is crucial for troubleshooting and planning. This slide helps you visualize why RTTA varies across different LLMs. This figure visually illustrates contributors to RTTA variance across the models. It shows where each model gains or loses time during processing and delivery. Visualization helps simplify complex numeric data, making performance trends easy to understand. By reviewing this figure, you can identify which architectural factors impact latency most. It supports better planning and model selection for specific tasks. Use this as a reference when considering LLM deployment in your environment. ChatGPT 4o consistently demonstrated the lowest RTTA across most workloads, especially in translation and conversational tasks. Gemini showed strong performance in retrieval-heavy tasks, but experienced latency spikes due to live crawling. Llama, while slower in terms of RTTA, provided high-quality structured outputs ideal for deep analysis. Each model's strengths are aligned with specific workload types. Knowing these strengths helps optimize your deployment strategies. It allows you to balance speed, quality, and consistency based on task requirements. Architectural design directly affects RTTA and user experience. Streaming models like ChatGPT 4o enable low latency and responsiveness for interactive environments. Live retrieval models like Gemini provide freshness but introduce variability. Structured reasoning models like Llama offer consistent, high-quality outputs with higher latency. Understanding these architectural differences ensures your model choice aligns with your workflow speed and depth requirements. This slide explains how architecture translates into user-visible latency. It is key to making informed decisions about LLM deployment. Workload type significantly impacts RTTA performance across models. Translation and repetitive generation tasks favor streaming models like ChatGPT 4o for low latency. Retrieval-augmented generation tasks are well served by Gemini when freshness is prioritized. Multi-step analytical tasks align with Llama, which handles complexity well despite higher latency. Teams should match models to workload types to maximize productivity. This approach ensures efficient use of compute resources and user satisfaction. The right alignment can significantly reduce perceived system delays. This slide helps you interpret why RTTA varies across models and workloads. Variance is tied to architecture, workload type, and infrastructure factors. Our findings align with prior studies, reinforcing these patterns as consistent. By understanding the causes of variance, you can plan deployments that minimize delays while maximizing output quality. This knowledge is valuable for developers and decision makers. It supports aligning technical architecture with operational goals. Based on our analysis, we recommend using ChatGPT 4o for interactive, latency-sensitive workflows where speed is critical. Gemini should be used for retrieval-heavy tasks requiring up-to-date information, accepting some latency variability. Llama is best suited for structured batch analysis tasks, prioritizing depth and quality over speed. Matching models to your workflow will enhance productivity and user satisfaction. This slide provides clear guidance for practical deployment. Use these recommendations to align your large language model strategy with your operational needs. RTTA differences are not minor. They compound in scaled environments and integrated pipelines. A model that saves seconds per interaction can result in hours saved at scale. This impacts developer workflows, content generation, and customer-facing applications. Understanding these practical implications allows teams to maximize productivity. It also supports planning for compute resource allocation and system design. This slide emphasizes why benchmarking matters for real-world impact. In summary, we have shown that Llama, ChatGPT 4o, and Gemini each have unique strengths and trade-offs in RTTA performance. ChatGPT 4o offers speed, Gemini offers freshness with variability, and Llama offers depth with higher latency. RTTA benchmarking helps teams select the right model for their workflows. This alignment ensures efficiency, productivity, and user satisfaction. We encourage you to use these findings to guide your LLM deployment strategies. These slides list the references supporting our benchmarking methodology, architectural analysis, and prior studies. They provide the foundation for the claims made in this presentation. Review these references for deeper technical insights. They are aligned with IEE standards for technical publications. We acknowledge the researchers and engineers whose work informed this benchmarking study. Use these references as resources in your continued research and planning. Based on our findings, we recommend that teams consider RTTA as a critical factor in LLM selection, particularly in environments where interaction speed directly affects user productivity. Teams should also evaluate the cost-performance trade-offs and be aware of how latency compounds at scale, impacting workflows in enterprise environments. A careful assessment will help balance consistency, speed, and information freshness aligned with business goals. Conclusion: our benchmarking study highlights that RTTA differences, while sometimes small in absolute terms, have significant cumulative impacts on workflows and user satisfaction at scale. Architectural choices such as streaming versus crawling significantly affect these outcomes. As teams continue to adopt LLMs, considering RTTA alongside accuracy and cost will be essential for effective and efficient deployment. Thank you for attending this presentation on benchmarking Llama, ChatGPT 4o, and Gemini for RTTA. For further discussion, collaboration opportunities, or detailed data access, please feel free to contact me at sfibish@comcast.net. Your engagement and questions are welcome as we continue to optimize LLM deployments for practical, real-world scenarios. Thank you for your attention. Contact for collaboration or questions on RTTA benchmarking.